Today we will discuss the binomial theorem, which is the third class of the binomial theorem. In the last two classes already we had discussed how to expand a binomial expansion using either Pascal triangle or using combination notation. Also the middle term in a binomial expansion. Today these are the outlines of today's class discussion. The independent term in binomial expansion. What is the meaning of independent term? How to find the independent term in a binomial expansion? That is on finding the terms independent of the variable in a binomial expansion. So first of all let us to find what is the meaning of the independent term. By independent term we mean the term which is not dependent on the variable. For example, suppose I write a term here 7x or 7x square. Now this here, these are two terms or monomial single term which contain x. In the first term here x present, in the second term x square present. I write here another term 7, this is also a term, but the third term no x, or this is the term free from x. Now see, in the first term 7x, x power is 1, in the second term x power is 2, but I can write 7 as 7 into x to the power 0, because already know any number or any term to the power 0 is 1. So that is the term which is independent of x. The exponent of the variable must be 0. Considering this discussion, come to an example. Suppose consider the expansion x plus 1 by x whole to the power 4. Already know how to expand the expansion. Already know, since the exponent here is 4, there are 5 terms. Using either Pascal triangle, find the coefficients, or using combination notation. Here see 1, 4, 6, 4, also 1. 5 terms. 1 can be written as already know 4C0. This is 4C1, 4C2, 4C3, and the last one is 4C4. 4C0, 4C4 is either using combination notation or Pascal. Both are 1. 4C1, 4C3 using the formula combination. Both are 4. 4C2 is 6. And after simplification, it will be x to the power 4 plus 4x square plus only 6 plus 4 by x square plus 1 by x to the power 4. Now see, in this expression, there are 5 terms, out of which only one term, that is a 6, do not contain x. But all other terms, first one x to the power 4, 4x square, 4 by x square, 1 by x square, all are dependent on x. Since in the third term 6, no x present, this is called independent term. That means the constant term which do not contain x is called independent term. I read the same thing here. Here the term free from the variable x is 6. Hence the independent term of x is 6. That is the term containing no x or free from x. Clearly, in the independent term, the index of the variable must be 0. Now, consider the same thing, how to find the independent term in a binomial expansion. I read the same thing again. The independent term in a binomial expansion is the constant term that is free from the variable. And steps to find the independent term. Suppose in a binomial expansion, x plus 1 by x to the power 5, after expansion we get 6 terms. That means how to find without expanding, directly find the term which do not contain x. These are the steps. Find any term means general term. Find the general term using our previous formula tr plus 1 Already you know TR plus 1 value is equal to TR plus 1 value is nothing but NCR A to the power n minus R B to the power R, where A is the first term in the binomial given and B is the second term, n is the exponent, R value takes anyone. So next, after finding the general term, set the exponent of x in the general term to 0. Exponent is the power of x in the first term and also second term. After simplification, combining, we get a single x term whose power or exponent take 0 and find the value of r. And putting the value of r in the previous one, that means TR plus 1, we get the required independent term of the given binomial expansion. Now, taking or considering these three steps, come to an example. Find the term independent of x in the expansion 2x minus 1 by x square x whole to the power 10. Now see here, this is the compared to our a plus b to the power n. A is equal to here 2x, b is equal to minus 1 by x, and exponent n is equal to 10. Three known facts given. So as per our discussion, let r plus 1th term or same as tr plus 1 be the independent of x. Now to find the tr plus 1, whose value nothing but 10cr or c10r x to the power or a to the power 2 10 minus r or n minus r, that is the 2x to the power 2x is the a here, and b is minus 1 by x whole to the power r. Keep bracket because minus sign is the important one. So since negative here, we take a after simplification minus 1 to the power r to beginning, c10r into all r multiplication, and since 2x here, we take a 2 to the power 10 minus r, also x to the power 10 minus r, and since another x here, x to the power minus r, from this last term, combining 10 minus r with again minus r, we get x to the power 10 minus 2r. So as per our procedure of independent term, take the power or index of x is equal to 0. So for this term to be independent of x, take 10 minus 2r is equal to 0, or after simplification r we get is equal to 5. So clearly, since r is equal to 5, as per our procedure, here r is equal to 5, that means 5 plus 1. I write here 5 plus 1th term, that is the 6th term, is the required independent term. So let us to simplify the 6th term 1, but without x. Clearly, the 6th term do not contain x. So minus put here r value in this expression, but without x. Minus 1 to the power 5, c 10 5, 2 to the power 10 minus 5, I write here, and after simplification it will be minus 1 to the power odd number is always minus, so minus c or 10c5 2 to the power 5, nothing but 32, and after simplification it will be minus 8064. Hence the independent required independent term in this expansion is minus 8064. Similarly, we can take other example. Find the independent term in expansion of x square plus 1 by x to the power 12. Mark here a is equal to here x square first term, b is positive minus 1 by x, n is equal to the power index is nothing but 12. So using the same format, let tr plus 1 be the independent term. Next, find the value of tr plus 1 Formula is NCR. Here n is equal to 12. 12 CR. A to the power n minus r. A is x square whole to the power 12 minus r. B is nothing but 1 by x whole to the power r. And simplification, on simplification we get 12 CR x to the power 24 minus 2r, and x to the power it is nothing but minus r, and combine the x variable values to exponent again to 2r minus r nothing but 3r. And for independent term, already I told the power or index of x should be equal to 0. Therefore 24 minus 3r is equal to 0, or simplification on r we get 8. Now put the value of r in the tr plus 1 term, that means only the expression 12cr. Therefore the independent term is, or in the expansion, equal to 12c8. You can simplify 12c8 using a combination format: 12 into 11 into 10 into 9 into 8. 12 into 11, 10, 9, 8 into 7 into 6 into 5 up to 1, 12 factorial by 8 factorial into 12 minus 4 factorial, and after simplification we will check here, it will be 495. Clear? So this is the procedure how to find independent term in a binomial expansion. Next class we will discuss more about the binomial expansion. Today this much. Thank you.